A node can have minimum degree 1 and maximum degree n. Nodes which have degree 0, that means E, F, G has not connected to any other edges, so it has the degree 0, that is called as leaf node. A vertex with degree 1 is the leaf node and the degree of the internal node is at least 2. The root node is always considering at level 0. Hello everyone, I am Shweta, Computer Science faculty. So already I have discussed all the topics except this tree concept in 4th unit. So today I will explain the last concept in your syllabus, that is trees. So what is the definition of tree? I hope you know the structure of tree, is it right? So now first you have to understood the concept of cycle. So what is cycle? Cycle is a closed path. It's an example for cycle. Cycle means already we have studied this in graph theory, right? So cycle means it's a closed path. So what is this tree? A graph which has no cycle is called as tree. That is called as acyclic graph. A graph which has no cycle is called an acyclic graph. And a tree is an acyclic graph. So you can write that a tree is an acyclic graph, or graph having no cycle is called as a tree. So now this is an acyclic graph and this is an acyclic graph. So these are the example for tree. But this is a closed path called as cycle. So definition of tree is an acyclic graph. A tree or general tree is defined as the non-empty finite set of elements. Example, so here you have root and it has finite set of elements, clear, and called as vertices or nodes, having the property that each node can have minimum degree 1 and maximum degree n. So now this is the root. So what is the degree of this root? So degree means it connect to the two nodes. What is the degree of this root? So it connected to two edges. So degree is 2. And what is the degree of this node? So 1 and 2. And what is the degree of this node? 1 and 2. What is the degree of this node? 1 and 2. Clear? So a node can have minimum degree 1 and maximum degree n. So it can consist of n number of degree. Clear? This is called as tree. And now an acyclic undirected graph. So what is undirected graph? It has no direction, called as undirected graph, that is connected is known as a tree. So this is an example for general trees. And for a tree with n number of vertices. So it can consist of n number of vertices. The number of edges is n minus 1. If a tree consists of n number of vertices, so it has n minus 1 edges. N minus 1 edges. And the vertex with degree 1. A vertex with degree 1 is the leaf node and the vertex with degree 1. So example, a vertex with degree 1 is the leaf node and the degree of the internal node is at least 2. So here a vertex, here it is a vertex with 1 degree is the leaf node. A vertex with 1 degree is the leaf node. So now you can consider as a leaf node. The degree of this internal node is at least 2. So the degree of this internal node is at least 2. Clear? So now this is a basic information about the tree. And now what are the properties of tree? Very important question. Explain the properties of tree. There is only one path between each pair of vertices of a tree. There is only one path. So now it has one path between each pair of vertices of a tree. And if a graph G, there is one and only one path between each pair of vertices G is a tree. Now here it is a root node and it consists of so many nodes. Clear? So now a tree T with n vertices as n minus 1 edges. Already have discussed this. If a tree has n vertices, it has n minus 1 edges. And a graph is a tree if and only if it is a minimal connected. Is it clear? These are the main properties of tree. And terminologies of tree. So you can expect these questions for 2 marks. Very important questions. Root node. So what is root node? Give an example. This is the unique node in the tree in which further subtrees are attached. Example. So here I draw one tree structure. So now what is root node? Root node is a unique node. So now it is the unique node in the tree in which further subtrees are attached. So here subtrees means this is the subtree, this is the subtree. The root has 3 subtree. Clear? This is called as root node. It has attached to the subtrees. And here example for root node is A is called as root. And next is degree of node. So what is the definition of this degree of node? The total number of subtree attached to that node. The total number of subtree. So now here the degree of this root is 1, 2, 3. B, C, D is connected to the root node. And the degree of this B is again 1, 2, 3. Is it clear? And what is the degree of this C? It has not connected to any edges. So it is 0. So now the total number of subtree attached to that node is called as the degree of the node. Example, for node A, the degree is 3. For node E, the degree is 0. For node E, degree is 0. Clear? So node C, degree is 0. Node D also degree is 0. For node A, degree is 3. Node B, degree is 3. Is it clear? 2 marks question. And next terminology is leaf nodes are also called as terminal node. And what is the definition of this? Leaf nodes. These are the terminal nodes of the tree. So terminal nodes of the tree. So now this is called as leaf node. So this is the terminal nodes of this tree. The nodes which have degree 0. Already I told that nodes which have degree 0, that means E, F, G has not connected to any other edges. So it has the degree 0, that is called as leaf node. So now the node which has degree 0 are called as leaf nodes of the tree. These nodes are always present at the end of the tree. Clear? This is the beginning of the tree, that is root node, and this leaf node are always present at the end of the tree. Clear? This leaf node are present at the end of the tree. Example E, F, G and C and D. Clear? So example for this leaf node is E, F, G, D, C. E, F, G, D and C has no example for the leaf node is E, F, G, D, C. So now C has degree 0 and D also degree 0, and for node E, F, G has not contains any other node. Clear? This is called as leaf node. So now the nodes which have degree 0 is called as leaf node. And what is internal node? The nodes in the tree which are other than leaf nodes. The node which has tree other than leaf nodes and the root node are called internal node. So internal nodes are B and D. So this internal node consists of the leaf node E, F and G. Clear? The node which are other than leaf nodes are called as internal nodes. And next terminology is parent node. Very important question. The node which is having further sub branches is called the parent node. That means a node which is having further sub branches. Now this is called as root node, and this is the parent of this node B, node C and node D. Clear? And B is a child of this A. So, and B is a parent of this node E, F and G. Got it? Now, the node which is having further sub-branches, further sub-branches is called the parent node. So, example, B is parent node of E, F, G. Got it? D has two nodes means, so D is the parent of this another nodes. Next is level of tree. The root node is always considering at level 0. That means the root node is always considering at level 0. And the next level is level 1. The root node is always starts from the 0 level and the next root node level is level 1 and this is level 2. So in this tree, it has 3 levels. Clear? So level of tree, the root node is always considering at level 0 and then its adjacent children are supposed to be at level 1. So now B, C, D are the children of root A and so on. So next is E, F, G are the children of this node B. Clear? This is a parent node of this E, F, G, that is the level 3. So always the root node starts from the level 0 and the next adjacent ones are level 1 and the next one is level 3, level 4, level 5, etc. So here level 0 is node A, level B, C, D is level 1 and E, F, G is level 2. And next is height of the tree. Height of the tree means that is the depth of the tree. The maximum level is the height of the tree. So now you can observe this tree. The maximum level is called as the depth of the tree. Example, the height of the tree is 3. So how many branches are there? First, second and third. So now height of the tree is 3. 1, 2, 3. And next is degree of tree. The maximum degree of the node in the tree is called the degree of the tree. So now the degree is A. For A node, degree is 1, 2, 3. For B node, degree is E, F and G. And next terminology is an edge. So connectivity between two nodes. Edge means, so now the connectivity between two nodes is called as edge. Now what is the connectivity between A and C? This is the connectivity between two nodes, that is node C and node E. And what is the connectivity between this node? So this is the edge B and F. Clear? So now next one is path. Sequence of node connected one after the another through edge. Sequence of node. So now for connecting from E to B, there will be a path. And connecting from C to A, there will be a path. Clear? That is called as sequence of node connected one after other through edge. Through an edge, it is connected from one to other node. So these are the main terminologies of trees. Very important question for 2 marks. So just write the definition and example for this. And next is very important question, spanning tree. So what is this spanning tree? So a spanning tree is a subset of an undirected graph. Spanning tree is a subset of an undirected graph that has all vertices connected by minimum number of edges. So here all the vertices and edges are connected from minimum number of edges. Now if all the vertices are connected in a graph, then there exists at least one spanning tree. So now all this graph has at least one spanning tree. A spanning tree is a subgraph of an undirected connected graph which includes all the vertices of the graph with a minimum possible number of edges. And if a vertex is missed, then it is not a spanning tree. Clear? If the edges is missed, means it is a spanning tree. If the vertex is missed, means it is not a spanning tree. Now, what are the properties of this spanning tree? A spanning tree does not have any cycle. So now, I'll write one example. A spanning tree does not have any cycle. I'll give one example. Now, this is one graph. That means closed path, that is a cycle. So, a spanning tree does not have any cycle means by using this graph, we can draw a spanning tree. So, how to draw a spanning tree? Now, I'll use this graph that is closed path. I'll write the spanning tree. That means it is not a closed path, then we can consider as it is a spanning tree. Clear? So for this graph, I have written one spanning tree and you have to miss one edges. Now, it is an example for spanning tree for this given graph, and this is one spanning tree, and only 3 spanning trees we got from this graph. Is it clear? So now it does not have any cycle. So here this is an example for cycle. It consists of all the edges and vertices. So here I missed this edges. Now it is a spanning tree. I have removed these edges. This is a spanning tree and this is a spanning tree, because spanning tree means does not have any cycle. Clear? And any vertex can be reached from any other vertex. Clear? So here I missed this edge and I missed this edge, and here I missed this edge. Clear? This is an example for spanning tree. So now another example for spanning tree. So now it is a closed cycle. Is it right? Now I'll use this closed cycle. I'll draw a spanning tree. First spanning tree and second one. Next. And everything I have covered, right? So now in the first tree, so I have removed this edge. In the second one, I have removed this, third one and fourth one. So now to this graph, I got 4 spanning trees. Is it clear? So spanning tree means it does not have any cycle or called as a spanning tree. And next one is minimum spanning tree. So now minimum spanning tree. What is the definition of minimum spanning tree? Minimum spanning tree is almost a spanning tree, but the cost is minimum among all the spanning trees are called as minimum spanning tree. Is it clear? So now I'll give an example. Here, this is an example for cycle. Now I'll use this graph. I'll find out which one is a minimum spanning tree. So it has 5 and this is 3 and 2. So edges value have given 5, 3, 2. Now you have to draw a spanning tree first. So I'll draw this first spanning tree and next spanning tree and next spanning tree. Now add all the edges among this spanning tree. Add all the edges. Find the value of these edges. You will get the minimum spanning tree. Now add these two values. 5 plus 2 is equal to, I got 7. And 2 plus 3, 5. And 5 plus 3, 8. So now, which is the least value here? So least value is 5. Now, the minimum spanning tree is, this is a minimum spanning tree. So what is the definition? Minimum spanning tree is a spanning tree where the cost is minimum. So among these 3 costs, have to choose the least cost, because cost is minimum among all the spanning trees. That is called as a minimum spanning tree. So the cost is least in this spanning tree. So I will choose this is a minimum spanning tree, because 2 plus 3 is equal to 5. So this is a minimum spanning tree among other spanning trees. Clear? You can give this example also. And what are the properties of minimum spanning tree? A spanning tree does not have any cycle. So already I told that a spanning tree does not have any cycle, and any vertex can be reached from any other vertex. So any vertex can be connected to any other vertex also, and the total number of spanning trees with n vertices that can be created from complete graph is equivalent to power n minus 2. Is it clear? Example, if you have 3 number of vertices and here 3 minus 2, how many spanning trees you will get? 3 spanning tree you will get. And if you have 4 number of vertices, so n minus 2 means 4 minus 2, 4 power 2 is equal to 16 spanning tree, you will get it. Is it clear? So this is an example for minimum spanning tree. If we have n is equal to 4, the maximum number of possible spanning tree is equal to 4 power 4 minus 2 is equal to 16. Thus, 16 spanning trees can be formed from a complete graph with 4 vertices. So, with 4 vertices, how many spanning trees we will get? We will get 16 spanning trees. Is it clear? And example for minimum spanning tree. So here I have one undirected graph. So the value from node A to node B is 1, 4, 5, 2 and 3 for each vertex. This is undirected graph. And first you have to write the spanning tree. So now the spanning tree cost is, first I will take this. So I am removing this edge. This edge have removed here and this edge also I have removed. The minimum spanning tree is 4 plus 5 plus 2. Clear? Because I got only this. Here, if you connected this edge, so you will get cycle. So it is not a spanning tree. So have not connected this edge and have not connected this edge. So the final one is cost is 4 plus 5 plus 2. 4 plus 5 plus 2 is equal to 11. And coming to the next one, minimum spanning tree. So here have not connected this again because it will get cycle. Have removed this 2 edge. So have removed this 2 edge, this 3 edge and edge 5. So you will get 4 plus 1 plus 5 plus 2, that is 7. So which is a minimum spanning tree here? So this is called as minimum spanning tree. Is that clear? So you can write all the possibilities here. So here this is a first spanning tree and you can remove this and you can remove this and you can remove this. So these are the example for minimum spanning tree. So please draw a spanning tree, then you can find the minimum cost. So this is about your spanning tree. Very simple concept is tree and graph. Please don't skip any topics in graph and tree. So easily you can score complete marks in graph theory because it is very simple concept, graph theory and trees. Clear? So in trees, you are studying the definition of tree and the terminologies of tree and the properties of tree and the example for root node, leaf node, child, parent node, etc. And you have spanning tree, definition and properties and example problems and minimum spanning tree. So the definition of minimum spanning tree, properties of minimum spanning tree and the example graph for minimum spanning tree. Clear? So these are the main topics you have to study in tree structure. These are the main topics you have to study in the concept of trees. So now already we have studied the spanning tree and minimum spanning tree. So minimum spanning tree consists of 2 main algorithms, that is Kruskil's algorithm and Prim's algorithm. Is it clear? Very easy concept, Kruskil's algorithm and Prim's algorithm. In tree, you are studying the concept of spanning tree and minimum spanning tree. So minimum spanning tree can be categorized into 2 algorithms, that is Kruskil's algorithm and Prim's algorithm. So you can expect this algorithm and problems also. Clear? So this is your last topic that I will explain it in my next session. So this is about your basic structure of trees and spanning tree and minimum spanning tree. So in my next session, I'll discuss Kruskil's algorithm and Prim's algorithm. Thank you.